ഇതാണ് ചോദ്യം. 2 events. ഒരു സെക്കൻഡ്. Two events occur on ground at a separation of 5 kilometers and a time difference of 1 millisecond. Okay. അപ്പോൾ നമുക്ക് ഇതിന് ഇങ്ങനെ എഴുതാം. ഡിസ്റ്റൻസ് സെപ്പറേഷൻ എന്നുള്ളത് നമുക്ക് ഡെൽറ്റ എക്സ് എന്ന് എഴുതാം. ഓക്കെ, ഡെൽറ്റ എക്സ് നമുക്ക് 1 ഡയമെൻഷൻ ഇതായിട്ട് എടുത്താൽ മതി, കാരണം ആ ഡയമെൻഷൻ നമുക്ക് എപ്പോഴും എക്സ് ആക്സിസിനെ അലൈൻ ചെയ്യാമല്ലോ. അപ്പോൾ ഡെൽറ്റ എക്സ് എന്ന് പറയുന്നത് 5 കിലോമീറ്റർ. 5 കിലോമീറ്റർ എന്ന് 5 × 10⁻³ മീറ്റർ. ഓക്കെ, അതുപോലെ ഡിഫറൻസ് ഇവന്റ്സ് തമ്മിലുള്ള ടൈം ഡിഫറൻസ് എന്ന് പറയുന്നത് 1 millisecond ആണ്. ഡെൽറ്റ ടി ഈസ് ഈക്വൽ ടു 1 × 10⁻³ സെക്കൻഡ് അല്ലേ? മില്ലി സെക്കൻഡ് പറഞ്ഞാൽ ശരി. ഓക്കെ, ചോദ്യം ഇതാണ്. ഇവന്റ്സ്, അപ്പൊ ഇത് ഒരു ഫ്രെയിമിലുള്ളതാണ്. ഇത് കൃത്യമായിട്ടല്ല ഞാൻ വരയ്ക്കുന്നത്, പക്ഷെ ജസ്റ്റ് മനസ്സിലാൻ വേണ്ടിയിട്ട്. ഓക്കെ, ഇത് നമ്മൾ നോക്കുകയാണെങ്കിൽ തന്നിരിക്കുന്നത് നമുക്ക് ജസ്റ്റ് ഒരു ഇത് വരച്ച് നോക്കുകയാണെങ്കിൽ ടി വേഴ്സസ് എക്സ്, ഇതാണ് സ്പേസ് ടൈം. ഇതിലുള്ള 2 ഇവന്റ്സ് ആണ് തന്നിരിക്കുന്നത്. ഓക്കെ, ഈ ഇവന്റ്സ് തമ്മിൽ സ്പേസിന് സെപ്പറേഷൻ ഉണ്ട്. ഓക്കെ, ഇത് 2 ഇവന്റ്സ് ആണ് നേരുന്നത്. ഇത് കൃത്യം കണക്ക് നോക്കിയിട്ടല്ല ഞാൻ വരയ്ക്കുന്നത്, ജസ്റ്റ് മനസ്സിലാൻ വേണ്ടിയിട്ട്. ഓക്കെ, 2 ഇവന്റ്സ് ആണ്. ഓക്കെ, E1 ഇങ്ങനെ എന്തെങ്കിലും ആയിരിക്കും. ഓക്കെ, E2 ഇത് 2 ഇവന്റ്സ് ആണ്. റൈറ്റ്, ഈ ഇവന്റ്സ് തമ്മിലുള്ള സ്പേസ് സെപ്പറേഷൻ എന്ന് പറയുന്നത് ഇതാണ്. ഇതാണ് ഡെൽറ്റ എക്സ് എന്ന് പറയുന്നത്. ടൈം സെപ്പറേഷൻ എന്ന് പറയുന്നത് 1 millisecond. ഈ ഡെൽറ്റ എക്സ് സ്പേസ് സെപ്പറേഷൻ എന്ന് പറയുന്നത് 5 കിലോമീറ്ററാണ്. ഇതാണ് സംഭവം. ഓക്കെ, അതായത് ഇങ്ങനെ 2 ഇവന്റ്സ് ഉണ്ട്. ഓക്കെ, ഇങ്ങനെ 2 ഇവന്റ്സ് ഉണ്ട്. ഇത് തമ്മിലുള്ള സ്പേസ് സെപ്പറേഷനും അറിയാം, ടൈം സെപ്പറേഷനും അറിയാം. അതാണ് സാധനം. ഈ ഡിസ്റ്റൻസ് ഇതാണ് ഇതിന്റെ തമ്മിലുള്ള സ്പേസ് സെപ്പറേഷൻ. അതായത് 2 സ്പേസിൽ ഒരേ പോയിന്റ് അല്ല നടക്കുന്നത് ഈ ഫ്രെയിമിൽ നോക്കുമ്പോൾ. ഓക്കെ, നമ്മൾ വേറെ ഫ്രെയിമിൽ നോക്കുകയാണെങ്കിൽ ഒരു സെക്കൻഡ്. അപ്പൊ ഇനി ഇത് പറയുന്നത് വേറെ ഫ്രെയിമില് നമുക്ക് വേണമെങ്കിൽ ടി പ്രൈം എക്സ് പ്രൈം എന്ന് വിളിക്കാം. എന്താ പറയുക, ഇത് ജസ്റ്റ് വരയ്ക്കുന്നതാണ്, പിന്നീട് നമുക്ക് കൂടുതൽ ക്ലിയർ ആവാൻ വേണ്ടിയിട്ട്. പിന്നെ നമ്മൾ പ്രോബ്ലം ചെയ്യുമ്പോൾ ഇത്രയും ചെയ്യേണ്ട ആവശ്യമില്ല, ഇത് ഐഡിയ ക്ലിയർ ആവാൻ വേണ്ടി ചെയ്യുന്നേ ഉള്ളൂ. Events appear to be occurring at the same point in an inertial frame moving along the line joining the position of 2 events. അപ്പൊ ഈ ഫ്രെയിമിൽ ഇത് രണ്ടും ഒരേ പോയിന്റിലാണ് നടക്കുന്നത്. ഓക്കെ, സ്പേസിലുള്ള ഒരേ പോയിന്റിലാണ് നടക്കുന്നത് ഇവന്റ്. ഡെൽറ്റ എക്സ് 0 ആണ്, ഡെൽറ്റ എക്സ് പ്രൈം എന്ന് പറയുന്നത് 0 ആണ്. മനസ്സിലായി? ഇത് രണ്ടും ഒരേ പോയിന്റിലാണ് നടക്കുന്നത്. അതായത് എക്സ് എന്നുള്ള ഒരേ പോയിന്റിലാണ്, എക്സ് അല്ലെങ്കിൽ എക്സ് എന്നുള്ള ഒരേ പോയിന്റിലാണ് നടക്കുന്നത്. അപ്പൊ ഇതിന്റെ സ്പേസ് സെപ്പറേഷൻ 0 ആണ്, പക്ഷെ ടൈമിൽ സെപ്പറേറ്റഡ് ആണ്. ഓക്കെ, ടൈം സെപ്പറേഷൻ ഉണ്ട്, കാരണം രണ്ടും ഒരേ സമയത്തല്ല നടക്കുന്നത്, പക്ഷെ സ്പേസിൽ ഒരേ പോയിന്റിലാണ് നടക്കുന്നത്. ഓക്കെ, അപ്പൊ 2 ഇവന്റ്സ് ഉണ്ട്, 2 ഇവന്റ്സ് നടക്കുന്നുണ്ട്. ഓക്കെ, അപ്പൊ നമ്മൾ ഒരു ഇവന്റിൽ നിന്ന് വേറൊരു ഇവന്റിലേക്ക് പോകുന്ന ഒരു ഫ്രെയിമിലാണ് ഉള്ളത്. ഓക്കെ, അപ്പൊ ആ ഫ്രെയിമിൽ നോക്കുമ്പോൾ ഈ 2 ഇവന്റും ആ ഫ്രെയിമിൽ ഒരേ പോയിന്റിലായിരിക്കും സംഭവിക്കുക. ഇപ്പൊ ഇതാണ് നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്തത്. ഓക്കെ, കാൽക്കുലേറ്റ് ദി ടൈം ഡിഫറൻസ് ബിറ്റ്വീൻ ദി 2 ഇവന്റ്സ് ആസ് മെഷേർഡ് ഇൻ ദ മൂവിംഗ് ഫ്രെയിം. ഈ ഫ്രെയിമിലുള്ളതാണ് കണ്ടിട്ടുള്ളത്. ഇപ്പൊ ഇവിടെ നമുക്ക് ഇൻവേരിയൻസ് ഓഫ് ദി ഇന്റർവെൽ ഉപയോഗിക്കാം. നമുക്കറിയാം ഡെൽറ്റ എസ് പ്രൈം സ്ക്വയർ എന്ന് പറയുന്നത് ഡെൽറ്റ എസ് സ്ക്വയർ ആണെന്ന് പറയാം. റൈറ്റ്, അപ്പൊ ഇവിടെ ഡെൽറ്റ എസ് സ്ക്വയർ അല്ലെ ഡെൽറ്റ, ഈ ഇന്റർവെല്ലിൽ ലോറൻസ് ഇൻവേരിയന്റ് ആണ് ഡെൽറ്റ എസ് സ്ക്വയർ ഈക്വൽ ടു ഡെൽറ്റ എസ് പ്രൈം സ്ക്വയർ. റൈറ്റ്, അപ്പൊ ഇവിടെ നമ്മൾ എഴുതുകയാണെങ്കിൽ ഡെൽറ്റ എസ് സ്ക്വയർ എന്ന് പറയുന്നത് സി സ്ക്വയർ ഡെൽറ്റ ടി സ്ക്വയർ, ഓക്കെ, മൈനസ് ഡെൽറ്റ എക്സ് സ്ക്വയർ. ഇതാണ് നമ്മുടെ ഡെൽറ്റ എസ് സ്ക്വയർ എന്ന് പറയുന്നത് അല്ലേ. ഇവിടെ മൈനസ് ആണ് വരുന്നത്. is equal to delta s prime square. അപ്പോൾ ഡെൽറ്റ എസ് പ്രൈം നമുക്ക് ഇവിടെ എഴുതാം. ഓക്കെ, എസ് പ്രൈം എന്നുള്ള ഫ്രെയിമിൽ time difference it events. The events appear to be occurring at the same point. Okay, but delta x prime 0 delta t prime namukku. Okay, so this is equal to c square delta t prime square. Delta t prime right? So now delta t prime square is equal to delta t square. C കൊണ്ട് throughout divide ചെയ്യാണ് delta x square by c square. ഇനി just substitute ചെയ്താൽ മതി. Delta t നമുക്ക് already അറിയാം. Okay, അതിന്റെ സ്ക്വയർ എടുക്കുമ്പോൾ 10 raised to minus 6. 10 raised to minus 6 minus delta x square. Okay, so 25 into 10 raised to 10 raised to 6. Alle? Divided by c square. 9 into 10 raised to 16. Is that correct? Yeah. This is equal to delta t prime square. And delta. അപ്പോൾ ഇതിനെ സോൾവ് ചെയ്താൽ മതി. കാൽക്കുലേറ്റ് ചെയ്ത് കഴിയുമ്പോൾ നമുക്ക് കിട്ടുന്നത് അത് ചെയ്ത് കഴിയുമ്പോൾ നമുക്ക് കിട്ടുന്നത് ഇവിടെ 10 വേണം LCM എടുത്ത് നോക്കാം. ദിസ് ഇസ് ഈക്വൽ ടു 10 raised to minus 6 minus 10 raised to 6 by 10 raised to 10 raised to minus 10 അല്ലേ? അത് വേണേ LCM എടുത്തിട്ട് നോക്കുക ചെയ്യാം, അല്ലെങ്കിൽ ഈ c square കൊണ്ട് ഡിവൈഡ് ചെയ്യാതെയും ചെയ്യാം. ഓക്കെ, എനിവേ സോ ദിസ് ഫൈനൽ ആൻസർ ഇറ്റ് ബിക്കംസ് I think it's 1.6 second. ഇത് ചെയ്താൽ മതി, റൈറ്റ്? അങ്ങനെ വരുമല്ലോ, റൈറ്റ്? ഇത് ചെയ്തിട്ട് ഇതിന്റെ സ്ക്വയർ റൂട്ട് എടുക്കണം, റൈറ്റ്? യു ഡു ദിസ് ആൻഡ് ടേക്ക് ദ സ്ക്വയർ റൂട്ട് ബിക്കോസ് ദിസ് ഇസ് ഡെൽറ്റ ടി പ്രൈം സ്ക്വയർ, റൈറ്റ്? ന്യൂമറിക്കൽ ചെയ്യണ്ടല്ലോ, നമ്മൾ ചെയ്യില്ലേ?
ചെയ്യാം.
Okay, so this is how you solve this kind of problems. Okay. ചിലപ്പോൾ ഇത് ചെയ്യുന്നതിനേക്കാൾ എളുപ്പം ഇവിടെ തന്നെ സോൾവ് ചെയ്യുന്നതായിരിക്കും. ജസ്റ്റ് ടേക്ക് ദ LCM, റൈറ്റ്? അല്ലെങ്കിൽ ഫൈൻഡ് ചെയ്ത് കാൽക്കുലേറ്റ് c സ്ക്വയർ കൊണ്ട് എൻഡ് ഡിവൈഡ് ചെയ്താൽ. എനിവേ ഇറ്റ്സ് ജസ്റ്റ് ന്യൂമറിക്കൽ മാനിപ്പുലേഷൻ, റൈറ്റ്? യു ക്യാൻ ഡു ദാറ്റ്. Okay, let's go to the next one. Calculate the proper time interval between the occurrence of two events if in one inertial frame the events are separated by 3.6 into 10 raised to 8 meter and occur 2 seconds apart. Right? നമുക്ക് തന്നിട്ടുണ്ട്, we are given the events are separated by
delta x
3.6 into 10 raised to 8. Delta t തന്നിട്ടുണ്ട്. Okay, delta t is equal to they occur 2 seconds apart. Okay, so 2 seconds. ഇവിടെ നമുക്ക് ഇതേ കാര്യം തന്നെയാണ്. നമ്മൾ പ്രോപ്പർ ടൈം എന്ന് പറയുമ്പോൾ നമ്മൾക്കറിയാം പ്രോപ്പർ ടൈം ഇസ് റിലേറ്റഡ് ടു ഇൻവേരിയന്റ് ഇന്റർവൽ ബൈ ദിസ് റിലേഷൻ c square d tau square is equal to ds square, അല്ലേ? അതായത് ds square നമ്മൾ ഇങ്ങനെ എഴുതാണ്, if ds square is c square dt square minus dx square, then c square d tau square, where d tau is a proper time, is equal to ds square. All right, so you just calculate ds square and divide it by c square. The reason for this is that when you say the proper time, it means that it's occurring at the same point. Okay, in that frame it's occurring at the same point. All right, so the idea is this. What you mean by proper time is, so there are two events. Okay, event 1, event 2 is located. Okay, this time difference is, they occur 2 seconds apart. Okay, 2 seconds, and this distance is 3.6 into 10 raised to 8. All right, so what do you mean by proper time? Proper time is if you start from here, carry a clock to this point along this path. Right, the proper time means you take a clock from this event to this event. All right, or you go to a frame in which these two events are happening at the same point. Go to a frame in which these two events are happening at the same point, right? So in that frame, delta x will be 0, right, or the space separation will be 0. So the time measured on your clock will be the proper time, right? Will be the interval, So you'll have a factor of c square. Right? So basically what you are doing is that you are taking a clock from this event to this event. Remember, this is space time. This is space time. Just taking a clock from this point to this point, right? So in that clock's frame, you see that these 2 points are happening, these 2 events are happening at the same point in space. So the interval can be measured by just looking at the time on your clock, right? Okay, you can also write it as invariant interval, because we know that c square dt prime square minus dx prime square is equal to c square dt square minus dx square, right? And we are saying that it's proper time, so dx prime square is 0, right? We are saying dx prime square is 0, so you get c square dt prime square is equal to c square dt square minus dx square. Right? This is what we need to calculate, or we can use this directly, right? Because proper time is an important quantity. Proper time is an important quantity, and we know that the proper time is related to the invariant interval in this fashion. All right, that's it. So you just calculate ds square. Okay, you see that ds square is equal to 9 c square, 9 into 10 raised to 16 c square dt square multiplied by 4, okay, minus dx square, that is 3.6 into 10 raised to 8 square. But this is ds square. We need ds square by c square, right? So we have d tau square is equal to ds square by c square. So that's equal to, okay, that's equal to, this is divided by c square. So it is 4 minus 3.6 into 10 raised to 3.6 square into 10 raised to 16 divided by 9 into 10 raised to 16. Okay. These get cancelled, so it's actually 4 minus 3.6 into 3.6 divided by 9. So that's equal to 4 minus 3.6 by 9 is 0.4, right? 0.4
Yes.
into 3.6. Okay. So you just multiply that. What do you get? 72. 144. Yeah, well, 1.44, I think. Let me check the final. You can just solve it. Can you just do it now and see the answer? Give me the answer. This is d tau square. Then you need to take the square root of it. Okay. Can you just do it now and give me the answer? The numerical calculation.
Okay, okay.
What is this value? This is
2.56 ആണോ?
right, 2.56. So it's this is d tau square. Okay. So for d tau, you just take the square root. The square root of 2.56 is 16. 256 is 16, isn't it? Right.
Yes.
So it is 1.6. So the answer is 1.6 seconds. Okay. So there is a frame in which the events happen at the same point and which happen at a time difference of 1.6 second. Okay. Is that fine?
Oh, fine.
So such problems will be asked. You can easily solve. Okay. You just use the invariance of the interval. Right. Here's another problem. We have got an equilateral triangle. Okay. Equilateral triangle of side A. Let's move with the speed V, parallel to bisector of one of its angle. So you can choose any direction. So we have got a triangle here. Okay, it's an equilateral triangle. Let's say the side is A. Right, each side is A, and let's imagine it's moving like this. All right, parallel to bisector of one of the angle. Okay, this is the bisector. You can take the bisector of this angle. You could take the bisector of any angle. Right, for convenience, we choose this direction. Right. Okay, so let's say this is moving with the speed V, parallel to the bisector of one of its angle. Calculate the apparent perimeter. Calculate the apparent perimeter. So how do you do this? Apparent is not a good word. We take this direction. It's moving in this direction. All right. V.
Okay.
You'll see that this length is shortened, right? This height, or the height of the triangle, is shortened. All right. So you can say H is equal to, or H prime. Okay, H prime is equal to H into square root of 1 minus V square by C square. Is that correct?
Yes.
That's how the length contracts. But that's not enough. You need the perimeters. You need the sides. You need the sides. And this side you can calculate using the Pythagoras theorem. Am I right?
Okay.
So let's call this side as, let's say B. Okay.
3.
This is not apparent actually. It's okay. This apparent is not a good word, but that's how they asked it in the question. It's the length measured in some other frame. That's all. It's the length measured in some other frame. Okay. So this H prime and B, we can say B square is equal to the square root of this side. Right? So it's equal to A square plus, or we can write X. B is fine, right? You get it. Right. This is B in some other frame, right? Let's say this length is B in some other frame, all right? In the moving frame, it's B. So B square is equal to A square plus H square into 1 minus V square by C square, all right? That's equal to, the speed is not given, the speed is, yeah. And, okay, and what is H? What was H? The height of this triangle. We already know this side is A. Okay, so this this height. Okay, so
root 3 by 2. Yeah.
Exactly. Okay, this is H. This is A. This is A by 2. Remember, this is A by 2, and this is A. Am I right? It's A by 2 and this is A. So we know that H square is equal to, just use Pythagoras theorem, right? A square plus A by 2 square. Right? So that's equal to A square plus A square by 4. Is that correct? So that's equal to,
Yes.
5A square by 4.
Minus area.
Yes.
A square minus.
Yes, minus. I'm sorry. Minus A square by 4. So it is 3A square by 4. Okay, this is H square. So just substitute it here. You see that B square is equal to A square plus 3A square by 4. Okay, multiplied by 1 minus V square by C square. All right, we can get the final answer in terms of A. That's what we want. Okay. A and V, of course, A and V. Right? Because that these are the things that's given in the question. Right? So we can say B, or yeah, that's H prime. So we can say B is equal to A square plus, can we make it simpler? No, B is equal to, we can just take the square root. We can take A square outside. Okay, B square is A square plus 1 by 3 by 4, 1 minus V square by C square. Okay, so B is B measured length. B is the length of this side as measured from the moving frame. Okay. So in the moving frame, you see that, yeah, in the moving frame, you see that this height is H prime Okay, this length is A and this length is B. This is from the moving.
A square plus equation അങ്ങനെ വരുന്നത് a square plus h prime and square plus a square ആണ് a by 2 whole square ആണ് വരിക.
Sorry, a by 2 ആണ് അല്ലേ? A square by 4.
അതെനിക്ക് കൺഫ്യൂഷൻ.
Sorry, a square by 4. So we can take a square by 4 here. Is that correct?
Okay.
Yeah. So that here we'll have just a 3, right? That correct?
Okay. Correct.
Okay. So you see that so this B is equal to A by 2 square root of 1 plus 3 1 minus v square by c square. If you make a mistake somewhere, you can check. All right. Now this side also will be the same. All right. This side also will be exactly the same. Do the same calculation. Okay. So the perimeter P can be written as it's A plus 2B. All right.
Yes.
Okay. So that will be, I think. Let's test the calculations once again. Okay, so we have got this relation h prime is equal to h into square root of 1 minus v square by c square, and b square is equal to a square by 4 plus h square into 1 minus v square by c square. That's also correct. And h was 3a square by 4. H square was 3. All right, so the final answer should be, the perimeter should be a plus, okay, you just a into square root of 3 1 minus v square by c square plus 1. Is that correct?
Yes.
Okay, so if you take, you can maybe pull a outside and write it in this form. 1 plus, okay, so you write it, you can just pull a outside, so it's 1 plus the square root of you can write this as 3 plus 1. 3 plus 1 is 4, right? So it is 4 minus v square by c square. Is that correct? Or I made a mistake?
Yeah.
We can do that, right?
Okay.
So it's yeah. So it's I'm sorry. So this is equal to a multiplied by 1 plus this 3 minus 3 v square by c square. 3 plus 1 is 4. That is square root of 4 minus 3 v square by c square. Okay, that should be the answer. Okay, that should be the perimeter. Right. So we see that it's different from 3a. Right, it's different from 3a. Okay, so this is the answer in terms of the velocity and the one side of the triangle. Okay. That's okay, isn't it? You just be careful with this Pythagoras theorem and all that. Okay. All right.
ഏരിയ ചോദിക്കുകയാണെങ്കിൽ നമ്മൾ ഹാഫ് എ ബി കണ്ടുപിടിച്ചാൽ പോരാ അവിടെ?
Area ചോദിക്കുകയാണെങ്കിൽ it's easier, right? Because it's half bh, right?
ഹാഫ് അതില് ഇത് മാത്രം h
Yeah,
prime
it will
മാത്രം
only change. So the
കണ്ടുപിടിച്ചാൽ
area is easier, right? Area we see that a prime will be is equal to a multiplied by 1 minus v square by c square. That's all. Area will go like that. Okay. Because the height, right? So we can say that, so you can check this, all right? So if you take the area is equal to half bh, right? Half bh in this frame, right? So what happens in a prime, it will become half bh prime. It's moving along h prime direction, right? And what's h prime? That's equal to half b h multiplied by, is that correct?
Correct.
So this half bh is already a. So you see that a prime is equal to a into 1 minus v square by c square. You can use this formula directly. If the area is asked, you can use this formula directly. The area always goes like this, all right? Because when you take integral dx dy, all right, this one of this lengths will change by 1 minus v square by c square. That can be pulled out, and whatever remains would be the area. All right, so area will scale like this. All right, you can the area will go as a into square root of 1 minus. Similarly, volume also, right? V prime will be equal to v multiplied by 1 minus v square by c square. For perimeter, you need to do a little bit more work. Okay. That's all right, isn't it?
Oh, correct.
So here is another problem. Half-life of an unstable particle. The half-life of an unstable particle. The half-life of an unstable particle is 2. This is mu. Mu is micro, right? So let's say, let's write it as T1. Okay, T1 is equal to 2 into 10 raised to minus 6. Is that correct? Seconds. All right. Okay. When it is moving with speed 0.6 c. Okay, when it's moving with speed 0.6 c. Okay. T2 is equal to, in some other frame, right? In some other frame, calculate its half-life. We need to find T2 when it's moving at 0.8 c. Right? When it's moving at 0.8 c. Right? Now, how do we do this? How do we do this?
T prime is equal to T into 1 minus Vx by C square.
There are different ways to do this. Let me see.
Speed 0.6 c.
Okay.
Is the same frame? So
you can imagine it like this.
Same frame.
Yeah, you can imagine it like this. You are standing on the ground.
Direct formula apply
when it's going at 0.6 c, you know that the lifetime, it decays after, what is it, 2 into 10 raised to minus, what was it, 6, right? Yeah, 6 seconds. And when it is moving at 0.8 c, right, what would this be?
T is equal to gamma T0 formula apply.
Yeah, that can be done. All right, and then what will you do? You have to eliminate T0, right? So you just divide it and eliminate T0. Is there any other way of doing it? Is there any other? There may be more complicated ways to do this, but this is the easiest, I think. Right? I think that's the easiest. Calculate half-life when it moves with the speed of 0.8 c. All right, that's the easiest thing to do. All right, so you see that we can write, let's say T0 is the proper time, proper lifetime, okay, proper half-life. Okay, then we can write T1 is equal to T0 divided by square root of 1 minus and 0.6, that's 0.6 here, right? 0.6, so that's equal to 0.36. All right. Okay. Similarly, you can say T2. We don't know T2, but T2 is equal to T0 divided by square root of 1 minus 0.64. Am I right? Because it's 0.8.
Yes.
Now, if you do T1 by T2, okay, if you do or T2 by T1, let's say T2 by T1. If you take T2 divided by T1, you see that this term gets cancelled. All right. So that is T0 will get cancelled. So what you have is square root of 1 minus 0.36 divided by square root of 1 minus 0.64. Is that correct?
Correct.
Yeah, that's correct. Okay. So that's equal to square root of 1 minus 0.36 is 0.8. Am I right?
Yes.
And this is 0.6. Correct? right? So what you need is T2. So T2 is equal to 0.8 by 0.6. That's 8 by 6. 8 by 6. So this is equal to 4 by 3. Am I right?
Yes.
So it's 4 by 3 T1. Again, T1 is given. T1 is given as 2 microseconds. So T2 is equal to 4 by 3 multiplied by 2 into 10 raised to minus 6. Okay, this is one way to do this. All right. Okay.
Okay.
I can just calculate it, right? Or if one of the answers is given as something like 2.67, that should be the answer, right? Because it's basically 8 by 3. Yes, it is. So find the answer is, maybe the answer, sometimes the answer is given in the options. Okay. So that is 2.67 multiplied by 10 raised to minus 6, so microseconds. Okay. All right. Fine. Is there any other way to do it? You can think, right? Maybe there are other ways of doing it. Yeah, that's enough. I think we'll go to the next one. So here's another problem. An electron is accelerated. Okay, an electron is accelerated from rest to a speed 0.8 c by applying an electric potential difference. Okay, calculate the value of the potential difference. Calculate the value of the potential difference. Okay, so let's see how to do this. How can we do that? Applying an electric potential difference. Calculate the value of the potential difference. All right. So
lambda is equal to h by root 2 mqv എന്ന് പറഞ്ഞൊരു ഇക്വേഷൻ അല്ലേ?
yeah, you can use the kinetic energy there, right?
Yes.
That's one way of doing that. All right. So the question is this: calculate the value of the potential difference. Calculate the value of the potential difference.
അല്ലെങ്കിൽ EV is equal to half mv square എന്ന് കൊടുത്തിട്ടേ EV is equal to half mv square അല്ലേ?
No, that's good. You said EV is equal to half mv square. That's correct. Okay. What will it be relativistically? This is non-relativistic, am I right?
അതെ അതെ, അത് മാറ്റണം.
Yeah. So basically, EV is equal to kinetic energy. Right. So when an electron of charge E, right, or a charge E, so the basic idea you need to remember is that when a charge E is accelerated by a potential difference V, correct, the gain in kinetic energy it obtains is EV, right? The kinetic energy is EV. Is that correct?
Yes.
And what's the kinetic energy for an relativistic particle? It's gamma mc square minus mc square. Right? Gamma mc square minus mc square. Right? This is the total energy and this is the rest energy. So this would be the kinetic energy. Right? It's accelerated from rest. Right? So the gain in the kinetic energy is equal to EV. Is this fine?
Yes.
Right? So this is the formula I use. So now V is equal to, you can take this. This is the potential. V is equal to, you can take mc square outside. Okay. So that is gamma minus 1, right, divided by E. We can do that, right? And we know that the mass of the electron is 9.1 into 10 raised to minus 31 kilogram, right? And C square is 9 into 10 raised to 16, right? Divided by E is 1.6 into 10 raised to minus 19, okay? Finally, gamma minus 1, right? Gamma minus 1. What's gamma minus 1? It's
1 by root 2.
Yeah, the final. Yeah, this is the final kinetic energy. So it's 1 by square root of 1 minus 0.8 C. So 0.64, right? Is that correct?
Yes.
So we can write this as 0.61, 0.36. So it's 0.6, right? So maybe this is 10 divided by 6. Okay, minus 1. So that is 10 minus 6 is 4, 4 by 6. That's 2 by 3, right?
Mm.
So you just do that and you'll get 2 by 3. Now you just do this thing and you'll get the answer. Is it easy to do? I think it's easy to do. All right, it's 10 raised to minus 13. Also 10 raised to minus 19 here. Okay. And also 10 raised to minus 31. So this already becomes 10 raised to minus 15, right? Wait a second. What was it? 10 raised to minus 31. This 10 9 to 10 raised to 16. So you just simplify this, all right? You just simplify this and see if the final answer is 341 into 10 raised to 3 volt, all right? Or we can write as 341 kilovolt. Is this correct?
Okay.
You have to check. This maybe it's approximately. I just give you the final answer. Maybe this also. But if you calculate this, you'll get the final answer. Okay. Okay, that's how you do this. So the idea that we have used here is that when an electron is accelerated, all right, by a potential difference V, the gain in kinetic energy is EV. The gain in kinetic energy is EV. All right. This is the formula that we, and the gain in kinetic energy is the final kinetic energy minus initial kinetic energy. Right. Initial kinetic energy is given to be 0. The final kinetic energy is gamma mc square minus mc square. Right? So we have got gamma mc square minus mc square is equal to EV. All right. Now it's just a matter of solving for V. Okay. All other details are known. Is this fine?
Fine, fine.
All right. Just one more problem. This was asked for NET June 2012. Okay. So two events separated by. Right. So we've got. Let's just draw it. For future, we'll be seeing more of such diagrams. You don't need to draw it, but it's a good thing to draw, right? So two events separated by spatial distance 9 into 10 raised to 9 meter are simultaneous in one inertial frame. They are simultaneous in one inertial frame, all right? So simultaneous means this is t-axis, this is x-axis. Simultaneous means they are happening at the same time, okay? And their separation is 9 into 10 raised to 9 meter, okay? In some one initially. The time interval between these two events in a frame moving with a constant speed 0.8 c. All right. The time interval between these two events in a frame moving with speed 0.8 c. How do you do this?
ds square is equal to ds dash square എന്ന് കൊടുക്കുക.
Okay, and
എന്നിട്ട് ഡെൽറ്റ ടി 0 കൊടുക്കുക, ഡെൽറ്റ ടി പ്രൈം കണ്ടുപിടിക്കുക.
is that correct?
ഡെൽറ്റ എക്സ് തന്നിട്ടുണ്ടല്ലോ.
ഡെൽറ്റ എക്സ് ഉണ്ട്, പക്ഷെ ഡെൽറ്റ ടി ഇല്ലല്ലോ. ഡെൽറ്റ ടി 0 ആണ്, റൈറ്റ്?
0 ആണ്.
ഓക്കെ, പിന്നെയോ? ഡെൽറ്റ എക്സ് പ്രൈമും ഡെൽറ്റ ടി പ്രൈമും തന്നിട്ടില്ല, വെലോസിറ്റി ആണ് തന്നിട്ടുള്ളത്.
യെസ് യെസ്. ഡെൽറ്റ ടി പ്രൈം കണ്ടുപിടിക്കണം അല്ലേ? അല്ല, ഡെൽറ്റ എക്സ് പ്രൈം.
So this is not that difficult. You just use the Lorentz transformation, all right? That's the easiest way to do this.
Gamma into.
Yeah, exactly. So we have got this relation. Delta t prime is equal to gamma delta t. Let's take plus or minus, doesn't matter. It doesn't say which direction, all right? We have just asked the time difference, okay? So v delta x by c square, is that correct? All right.
Yes.
So here delta t is given to be 0. Delta t is given to be 0. So it's equal to gamma v delta x by c square. V is so the answer would be, we can say gamma v by c square multiplied by delta x. Okay, this would be delta key point. Right. So you should be careful. Okay, you may mistakenly use this some other. You can solve it using the invariant interval, but it's slightly more complicated. Okay, here it's the easiest way to do is to apply the Lorentz transformation. So you have to see which one is easier. All right. So we got gamma.
minus
Yeah, it doesn't matter, right? If moving in a constant speed 0.8 c, either direction ആണ് പറഞ്ഞിട്ടില്ല. Okay.
Okay.
Right, it could be in the opposite direction and then it's a minus there. Okay, it doesn't matter because we are asked the time interval. You are asked the time interval, so you can put a minus here, right? In the time interval delta t prime will have a minus sign, that's all. But the time difference would be, when you talk about the time intervals, we'll just say that they are 20 seconds apart or 40 seconds apart, that's all. Doesn't matter. All right. Okay. You can put a minus and then it would mean that you are just, so you can either look at it from a frame moving in this direction with 0.8 c, or you can look at it in a frame moving in this direction with 0.8 c. They haven't given the direction, right?
Okay.
So if you are using from this frame, you will have to use a minus there. If you are looking from this frame, you will have to use a plus there. Doesn't matter. In the end, what you will get is a time difference between these two events. They are not asking which event happened first. No, they have not asked that. All right. What's just the time separation? That's all they have asked. All right. So if you want, you can use the minus there, and then you'll get the final answer with the minus sign, but it doesn't really make any difference to the final answer. All right. So now we can just use this. All right. So that would be gamma is 1 by square root of 1 minus, we have got 0.8 c, so it's 0.64, all right, and v is 0.8 c, c square is 9 into 10 raised to 16, okay, and delta x is already given, 9 into 10 raised to 9. Is that correct? I think I did it right. Okay. Wait a second. This was c square, right? So that's equal to 1 minus 0.64 is 0.36. So when you take the square root, you get 0.6, right? So you got 0.8 by 0.6. No. Yeah, 0.6 into 9 into 10 raised to 9 divided by 3 into 10 raised to 9. Let's see. Okay. So that would be, what's answer? 8 by 6 is 4 by 3 multiplied by 9 by 3 is 3 into 10. Is that correct? That is 40 seconds.
Correct.
Right, 40 seconds. This is the easiest way to do it. Okay. Right. We'll just do one more and wind up. Okay. So here is a question. The kinetic energy and momentum of a relativistic particle are related by. Right? They are asking the relation between the kinetic energy and momentum. Right? The kinetic energy is K. Kinetic energy is K. Okay. So what's the relation between kinetic energy and momentum of a relativistic particle? So if you look at the kinetic energy, the right as K, we know that it's gamma mc square minus mc square, right? Okay. But we know that this also can be written as gamma mc square is E in terms of momentum. This can be written as square root of p square c square plus m square c raised to 4, right? Minus mc square. Is that correct?
Yes.
Okay. Now it's just a matter of rearranging to a form that we like here, right? So we need to solve for p. We need to solve for p. All right, so we see that square root of p square c square plus m square c raised to 4 is equal to k plus mc square. So you can square on both sides. You can square on both sides. This is a p square c square plus m square c raised to 4 is equal to k square plus m square c raised to 4 plus 2k mc square. Just square on both sides. Okay. And these two terms are gone. What you have is, so that's equal to, you can pull this k outside, k plus 2 mc square. Right? This is p square. P square. Okay, so P would be equal to K into K plus 2 mc square whole raised to 1 by 2. Okay, that answer is given. There's a C square here. So, okay, so it's 1 by C. Is that fine?
Fine, fine.
So option A is the correct answer. All right, option A. Okay. So I think that's all the problems I have for today. So we'll stop now. I'll collect more problems for tomorrow. We'll do more problems. Okay.
Okay.
And then in one or two classes, we have got two more important concepts. One is about the Minkowski spacetime. We'll do that in some detail. Okay, I'll take one class for that Minkowski spacetime. And there are also problems using a relativistic Doppler effect. Okay, so in one class, we'll also look at the relativistic Doppler effect. Right. So we have got a few kinds of problems to solve. One is using Minkowski spacetime. One is using one is about the particle collisions, all right, using energy, momentum conservation, etc. For that, it's the easiest way to do is to get familiar with the 4 vector notation, all right, 4 momentum and energy. Right? We'll do it using that, and we'll also do a couple of problems on Doppler effect. All right. So we'll stop for now unless you have any doubts. Have you any questions?
No, no. Thank you.
All right. Thanks.